Hello everyone. Today we shall understand about a pair of linear equations in two variables. To understand the concept, we have to know the equation first. Equation means in algebra is the equality of two algebraic terms or expression is called an equation. Linear equation, an equation involving only one variable with the highest power 1 is called a linear equation. Generally, linear equation in one variable is of the form ax plus b is equal to 0. Here x is the variable, a and b are constant terms. They are equated to 0, hence it is a linear equation. Since it has only one variable and it has only one value for x, it is called linear equation. Example, 4x minus 12 is equal to 0. In this example, if we solve for x, we get x is equal to 12 by 4, x is equal to 3. Similarly, we can solve for x here also. 3x minus 2 is equal to x plus 4. We get only one solution for x. That's why these type of equations are called linear equations. They have only one variable and they have only one solution for the variable. Linear equations in two variables. An equation of the form ax plus by plus c is equal to 0, where a, b, c are real numbers and a naught equals to 0 and b naught equals to 0 is called a linear equation in two variables. Example, 3x minus 2y minus 10 is equal to 0. Here x and y are the variables. 3, 2, minus 10 are all real numbers. Similarly, one more example is 2x plus y is equal to 9, where a is 2, b is 1 and c is 9. Again, it has the variables x and y. Therefore, these type of linear equations are called as linear equations in two variables. We have to note that a linear equation in two variables has infinitely many solutions. It is very difficult to find the solution, exact solution for this equation. Every point on the graph of a linear equation in two variables is a solution of the linear equation because it has infinitely many solutions. Every point on the graph means linear equation is a straight line. Every point on the line is a solution. Another way, every solution of the linear equation is a point on the graph. If we took alone the linear equation in two variables, only one equation, it is not possible to find the exact solution for that one. That's why we are going to take one more equation similar to the linear equation in two variables to get the exact solution. Those two linear equations together are called as pair of linear equations in two variables. In other words, two linear equations with same two variables are called a pair of linear equations in two variables. One more way we can define these as simultaneous linear equations. That means two linear equations involving two variables taken together to find exact solution are called as simultaneous linear equations. General form of pair of linear equations in two variables is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. where A1, B1, C1 and A2, B2 and C2 are real numbers such that a1 square plus b1 square not equals to 0 and a2 square plus b2 square not equals to 0. Example, 2x plus 3y minus 7 is equal to 0 and 9x minus 2y plus 8 is equal to 0. Here we have to note that the graph of every linear equation in two variables is a straight line. The graph x is equal to a is a line parallel to y-axis. The graph y is equal to b is a line parallel to x-axis. If we draw x is equal to 0 is the equation of y-axis and y is equal to 0 is the equation of x-axis. Why we have to study these linear equations in two variables? We are having so many situations in our daily life. To get the solution of those type of situations, we have to understand and we have to know about these linear equations in two variables. Let us consider such situations. Let us consider one of the situations like that. Here 10 students of class 10 took part in a mathematics quiz. If the number of girls is far more than the number of boys, how many boys and girls took part in the quiz? For this situation, let us consider number of boys be x and the number of girls be y. So according to the first statement, boys plus girls is equal to 10, that is x plus y is equal to 10. According to second statement, number of girls are far more than boys, means y is equal to x plus 4. That is, we have to write the given statements in the equation forms. Let us substitute equation 2 in equation 1. We get x plus 4 is equal to 10. By adding x plus x, 2x is equal to 10 minus 4. 2x is equal to 6 and we get x is equal to 3. Means number of boys are 3. To get the value of y, put x is equal to 3 in any one of these two equations. Let us put x is equal to 3 in equation 2. We get y equals 3 plus 4, y is equal to 7. Therefore, number of boys took part in the quiz x is equal to 3 and that of girls y is equal to 7. These two solutions x and y satisfies both the equations here. That means these two equations have exact solutions. In this case, we got exact solution satisfying both equations 1 and 2. Therefore, equations 1 and 2 have unique solution and they are consistent equations. Let us consider the same equations. X plus y is equal to 10 and y is equal to x plus 4. So we shall write that equation 2 in the standard form. Minus x plus y is equal to 4. Compare equation 1 and 2 with the standard form a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. We can observe that here a1 by a2 is equal to 1 by 1, b1 by b2 is equal to 1 by 1 is 1 and a1 by a2 is minus 1. we can observe that a1 by a2 is not equals to b1 by b2. Therefore, by observing the graph of these two equations, both lines intersect at a single point 3 and 7. Therefore, the graph of linear equations in two variables having unique solution, they are intersecting lines. Let us consider one more situation. Ludwig went to a stationery shop and purchased 2 pencils and 3 erasers for ₹9. His friend Pranav saw the same variety of pencils and erasers with Ludwig, and he also bought 4 pencils and 6 erasers of the same kind for ₹18. Let us represent this situation algebraically and graphically. We shall write the conclusion. Let us see. Let us again consider that the cost of one pencil be ₹X and that of eraser be ₹Y. According to mathematics, it can be represented as 2 pencils plus 3 erasers is equal to ₹9 means 2x plus 3y is equal to 9. According to second statement, 4 pencils plus 6 erasers is equal to ₹18, that is 4x plus 6y is equal to 18. By comparing equations 1 and 2 with standard form of linear equations in two variables, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. a1 by a2 is 2 by 4 is equal to 1 by 2. b1 by b2 is equal to 3 by 6 is equal to 1 by 2. c1 by c2 is equal to 9 by 18 is equal to 1 by 2. We observe that in this case a1 by a2 is equal to b1 by b2 is equal to c1 by c2. For these solutions, or for this statement, or for this situation, we observe that these two lines both overlapping on each other. Therefore, the equations have infinitely many solutions, hence they are dependent consistent. The graph will represent coincident lines. Now let us consider one more situation. Two rails are represented by the equations x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0. Let us represent the situation geometrically and we shall interpret our observation. Given two lines are x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0. Comparing equations 1 and 2 with the standard form of linear equations in two variables, that is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, a1 by a2 is equal to 1 by 2, b1 by b2 is equal to 2 by 4 is 1 by 2, and c1 by c2 is equal to minus 4 by minus 12, that is 1 by 3. We observe that a1 by a2 is equal to b1 by b2 but not equals to c1 by c2. If we draw the graph of these two equations, we get parallel lines. That means the lines do not intersect anywhere. Therefore, these equations have no solution, hence they are inconsistent. The graph represents parallel lines. We have to note that we can draw the graph and verify for consistent, dependent consistent and inconsistent linear equations in two variables. We find the unique solution algebraically by three methods called substitution, elimination or cross multiplication methods for consistent equations. but not for dependent, consistent and inconsistent linear equations. That means the equations those have only one solution, we can find the exact solution or unique solution for the consistent. They are consistent equations. For inconsistent and dependent consistent, it is not possible mathematically or algebraically to find the solutions. Let us consolidate our discussion. Pair of linear equations, that is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, where if a1 by a2 is not equals to b1 by b2, then the lines are intersecting, they have unique solution, hence they are consistent. In these equations, if a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then the lines are coincident lines, they have infinitely many solutions, hence they are dependent consistent equations. If the condition a1 by a2 is equal to b1 by b2, which is not equals to c1 by c2, then those two linear equations are parallel lines, they have no solution, hence they are inconsistent equations. So there are four methods to solve these pair of linear equations in two variables. One is graphical method, three algebraic methods such as substitution method, elimination method and cross multiplication method. Let us solve two linear equations in two variables by substitution method. Let us consider one of the problem or situation in our daily life. 10 years hence, the age of father will be 2 times that of the age of son. 10 years ago, the age of father was 6 times that of his son. What are their present ages? Let us write the verbal statements to algebraic form. For that, let us consider the present age of father be x years and that of son be y years. According to statement, 10 years hence the age of father will be x plus 10 and age of son will be y plus 10. Now according to first condition of the equation, x plus 10 is equal to 2 into y plus 10. By simplifying, x minus 2y is equal to 10 we get. Let us call that as equation 1. Again, 10 years ago, the age of father will be x minus 10 and age of son is y minus 10. According to second condition of the equation or statement, x minus 10 is equal to 6 into y minus 10. By simplifying, we get x minus 6y is equal to minus 50. Therefore, x is equal to 6y minus 50. Let us call that equation 2. To get the value of y, let us substitute equation 2 in equation 1. We get 6y minus 50 minus 2y is equal to 10. 4y is equal to 50 plus 10. Y is equal to 15. To get the value of x, now put y is equal to 15 in equation 2. Then x is equal to 6 into 15 minus 50. X is equal to 90 minus 50. X is equal to 40. Therefore, present age of father x is 40 years and present age of son y is equal to 15 years. Let us solve the two linear equations in two variables by elimination method. Let us consider one more situation. A fraction become 8 by 11 if 3 is added to both numerator and denominator. Also, if 3 is subtracted from the numerator and denominator, it becomes 2 by 5. Find the fraction. Let the numerator and denominator of the fraction be x and y respectively. The first condition, the numerator and denominator, if you add 3 to the numerator and denominator, that fraction become 8 by 11, means x plus 3 by y plus 3 is equal to 8 by 11. According to second condition, if 3 is subtracted from the numerator and denominator, the fraction become 2 by 5. That can be represented as x minus 3 by x minus y minus 3 is equal to 2 by 5. By solving first condition, cross multiply this, that is 11 into x plus 3 is equal to 8 into y plus 3. Multiply 11 to both these two, that is 11x plus 33 is equal to 8y plus 24. By grouping the like terms, 11x minus 8y is equal to 24 minus 33. It will terminates to 11x minus 8y is equal to minus 9. Let us call this as equation 1. Observe the second condition. Again by cross multiplication, 5 into x minus 3 is equal to 2 into y minus 3. Multiply 5 with x minus 3 and 2 with y minus 3. We get 5x minus 15 is equal to 2y minus 6. By on simplification, by grouping the like terms, 5x minus 2y is equal to 15 minus 6. Further, we get 5x minus 2y is equal to 9. Let us call it as equation 2. We have our intention is to eliminate one of the variables in these two equations. For that, let me consider I have to eliminate y from these two equations. For that, I am going to make the coefficient of y as unit. For that, let us multiply equation 1 with 1 and let us multiply equation 2 by 4. Then we get 11x minus 8y is equal to minus 9. 4 into 5, that is 20x, minus 4 into 2 is 8y is equal to 9 4s are 36. By subtraction, 20 minus 11 is 11 minus 20 is minus x. 8y plus 8y get cancelled here. Minus 9 minus 36 is minus 45. By eliminating minus sign on both sides, and 45 by 9 gives x is equal to 5 here. Now put x is equal to 5 in equation 1 to get the value of y. That is 11 into 5 minus 8y is equal to minus 9. 11 5 is the 55 minus 8y is equal to minus 9. 8y is equal to my 55 plus 9 is 64. Then y is equal to 64 by 8 is 8. Therefore, here x is the numerator digit, y is the denominator digit, then the fraction is x by y is equal to y by 8. Now let us consider in a situation to solve a pair of linear equations in two variables by cross multiplication method. From a bus stand in Bangalore, if you buy 2 tickets to Malleshwaram and 3 tickets to Yeshwanthpur, the total cost is rupees 46. But if you buy 3 tickets to Malleshwaram and 5 tickets to Yeshwanthpur, The total cost is rupees 74. Let us find the fare from bus stand to Malleshwar and Bangalore, Yeshwanthpur separately. Let the fare cost from bus stand in Bangalore to Malleshwaram be X and to Yeshwanthpur be rupees Y. According to statement, 2x plus 3y is equal to 46. That is 2x plus 3y minus 46 is equal to 0. Here a1 is 2, b1 is 3, c1 is minus 46. Second condition, that is second statement, according to second statement, 3x plus 5y is equal to 74. That is 3x plus 5y minus 74 is 0. Here a2 is 3, b2 is 5, c2 is minus 74. Now let us consider x by b1 c2 minus b2 c1 is equal to y by c1 a2 minus c2 a1 is equal to 1 by a1 b2 minus a2 b1, which gives x by 3 into minus 74 minus 5 into minus 64 is equal to y by minus 46 into 3 minus of 74 into 2 is equal to 1 by 2 into 5 minus 3 into 3, which gives by simplification x by minus 222 plus 230 is equal to y by minus 138 plus 148 is equal to 1 by 10 minus 9. X by 8 is equal to y by 10 is equal to 1 by 1. X by 8 is equal to 1 by 1 and y by 10 is equal to 1 by 1, means x is equal to 8 and y is equal to 10. The fare from bus stand in Bangalore to Malleshwaram is rupees 8 and fare to Yeshwanthpur is rupees 10. Let us take one more problem. For what value of k will the pair of linear equations kx plus 3y minus k minus 3 is equal to 0 and 12x plus ky minus k is equal to 0 have infinitely many solutions? Given equations kx plus 3y minus k of k minus 3 is equal to 0, 12x plus ky minus k is equal to 0. For a pair of linear equations to have infinitely many solutions, the condition is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. That is, k by 12 is equal to 3 by k is equal to k minus 3 by k. So, by comparing, k by 12 is equal to 3 by k and 3 by k is also equated to k minus 3 by k. Now for the first one, cross multiplication, we get k square is equal to 36 and 3k is equal to k square minus 3k. By simplification, k is equal to 6 and 3k is equal to k into k minus 3. K get cancelled, 3 is equal to k minus 3. By grouping, k is equal to 3 plus 3 is 6. The value of k that satisfying both the conditions is k is equal to 6. It is the value of k for which the pair of linear equations have infinitely many solutions. Other than this k is equal to 6, they are consistent equations. They may be dependent consistent or consistent. Thank you.